that this book likes to build. So we're just going to build on what we have already started working on, okay? So one of the things that we're going to do today is adding mixed numbers. And I know you guys have seen some of this before, so we're just going to keep going with it and make sure that we understand how to do it. So the example they give us is 2 1/5 plus 9 2/5. If you think about it in terms of pies or pizzas, eyes up here please. Okay, if we have 2 whole pizzas and 1/5, so imagine the last pizza cut into fifths, and you have 1 slice hanging out. Here, you have 9 whole pizzas and 2 fifths slices. So if I add 2 whole pizzas and 9 whole pizzas, how many whole pizzas do I have, Damon? 11, thank you. And then how many pieces do I have, Jamaica? Not the ones that are colored in. I only have the ones that are shaded. 3, right? 1/5 plus 2/5. So 3 out of how many slices, Jamaica? Each pie is out of how many slices? So if I take this slice and I put it in, I have how many? 3 out of 5. So the fractional part, just like adding fractions, as long as we have a common denominator. Okay? So if we have common denominators, it's as easy as saying 11 3/5. We take those 2 mixed numbers and add them together. Okay? It gets a little more tricky when you bring in denominators that aren't common, but you guys are pros at that. So if we come to our first example, 2 3/4 plus 3 1/8 and 7 1/2. Okay? Destiny, what is going to be the easiest common denominator to give all of these guys? 24? Is that the easiest? It's Destiny. Think about it, Destiny. You have a 4, an 8, and a 2. You think 16? Could I go even easier than that? 8. Okay, so start me off. This one, we've got an ace already, so we can leave it. Let's do 7 1/2. How many 8s is 7 1/2? 7 and how many 8s? We can just convert and expand only the fraction. Leave our whole number and expand our fraction. So how many 8s is a half? 4. Good. Okay, come on. If we only expand our fraction, keep our whole number, how many 8s is 3/4? If you have 3 out of 4, how many out of 8 means the same thing? 2 8s is the same. I have the 2. What do I need up here? If I need 3/4 to become 8s.
I'm not sure, but
6. You multiply by 2, right? 4 times 2. So we do both top and bottom by 2. You get 6. All right, so Jamaica, if I add up all the whole pizzas, how many whole pizzas do I have here? 12. Beautiful. 12 whole pizzas, and I know I'm going to have 8s on the bottom because that's my common denominator. And now, Destiny, if I take the tops and add them all together, how many slices do I have? 11. Okay, 11. But now, if you guys notice, we have an improper fraction inside of a mixed number. All eyes up here, please. All eyes up here. Okay? We can't have an improper fraction inside of a mixed number. That's never legal, never allowed. Okay? So our job is going to be to figure out how many we need to pull out of our fraction to make this guy a bigger number. Okay? So if we have 12, and then if we've got our pizza split into 8s, we know we have 8. How many are left over if I had 11? I have 8 over 8 here, and how many over 8 left to get 11 over 8? Who's up next? I think it's Demar. how many slices do I have here if I have a total of 11 over 8? Good. 3 slices filled in, right? So if I have 3 slices filled in, I can break that fraction up into 8 over 8 plus 3 over 8 to get me 11 over 8, right? So, Jamaica, how many wholes can I pull out of 11 over 8 to add to my 12? How many whole pizzas do we have in 11 over 8? Exactly, this guy right here. If I pull out 8 over 8 from my 12 over 8, I can add this 8 over 8 to the 12 and make him 13, right? And then if I pull out this 8 over 8, how many eighths are left? Destiny, what do we say? 3 eighths. So 12 and 11 over 8 is the same as saying 13 and 3 over 8. We're pulling out one whole. So we could just do, we know 8's on the bottom. 11 minus 8 gives me 3 over 8 plus 1 added there. Okay, you don't have to draw this picture every time, but show me your work here. Make sure that we understand 11. We're pulling out 8 because that's how many makes us 1. Where that 1 comes from. We have 3 left. That 12 becomes a 13. Questions on that? No? All right. Next example. Add 528 and 1/3. Plus 7,142. All right. Devon, help me out. What's going to be my common denominator here? 12. So we said we can just drop our whole number and then put our fraction out of 12. So Jamaica, how many 12ths? I need to make this 1/3 into 12ths. Your name is not Jamaica. How many 12ths? I need 1/3 to become 12ths. How many 12ths is 1/3? Okay, the best way, think about what you had to multiply 3 by to get 12. By 4, whatever you do to the bottom, you do by the top, so the top number will be 4. Okay, Destiny? How many 12ths is 3/4? 9. Okay, so now when I add these together, we have wholes, 528 wholes, 7,142 wholes, so you can add those together. 2 plus 8, Damon? 4 plus 2 plus 1? 1 plus 5? 7? Okay, so I have 7,670 wholes, plus how many parts of 12, Tamika? How many parts of 12? I added my wholes together, so I took care of this piece and this piece. I have 4 parts of 12, but I also have 9 parts of 12. So how many total parts of 12 do I have?
13.
How did you get 13? Beautiful. 13. But can I leave my answer like that? Nope. I can't. So let's erase that step. Give me some more space. So what do I need to do first, Destiny? If I see that I have an improper fraction here, we have to figure out how to fix it. No improper fractions in mixed numbers. Drill that into your brain. Inside mixed numbers. Okay? No improper fractions. So, how do I make 13 over 12 better? What do I do with it? Simplify. How do I do that? By what? Okay. How many times does 12 go into 13? Keep it going. 1 time. So, Damon, if I pull out one set of 12, one whole 12, how many shaking his head yes? Thank you, sir. Okay? So, adding fractions. The key is making sure that we can simplify our improper fractions, since we said no improper fractions inside mixed numbers. Okay? Good job. Alright, that brings us to rates. Rates, you guys have already started talking about. They're kind of the same as unit multipliers. It's just that you might be given the rate instead of the assumption of a unit multiplier. Okay? And every rate is going to be a ratio. They're going to tell you our ratio right now. 3 students, you guys, to 1 teacher. So our ratio is 3 to 1. 3 students to 1 teacher. We could also flip that and say there is 1 teacher to 3 students. So I could write that either way. 3 students to 1 teacher. That's us. Or we can say, just flip it, 3 students on the bottom to 1 teacher. Okay, so we can always flip our rate or our ratio depending on the information that we're given, which will hopefully make sense in a second. Okay, so a ratio is a comparison of 2 numbers, a comparison of students to teachers. Okay, can be written several ways. We've talked about 2. Sometimes you can use the word per. So rather than drawing a line and putting it over top of each other, we could say 3 students per teacher. Okay? So this per is the same thing as that bar right there. Okay? Questions on that? Come on? No? What can we substitute this bar for? What can we substitute this bar for? The bar cannot be substituted for teachers. We can sometimes, in place of the bar, write what? In place of the bar, we could write, that's how you need to focus, up here, okay? We can say per, 3 students per teacher. So if we wanted to take out this bar, we could substitute it with per. So Demond, if we take out the bar, you could substitute it with, one more time? Per, thank you. Question?
Isn't that a ratio though?
This here?
No, the
This.
students to the teacher, yeah.
Yeah, this is a ratio.
So we don't have to just say per or put a bar, we could say 2.
You could say 2. 2 won't be as common. The other way to do it would be like a colon. But we won't talk about those too much. I want to make sure we stick with pers and bars for now. Okay? Does that make sense?
But what if we forget a per?
If you write it in words, put the bar there. You can put it next to each other like that. But my preference is like this. Put it over top of each other so that you know it's like a unit multiplier, a unit conversion factor. Okay? Make sense? Yes, no? Okay. Alright. So, the other thing that we can do is what if we change this, and we talked about Miss Watson's class and our class right now, and we said there are 10 students per 2 teachers. What could we break that down into? Or we could flip it here. 2 teachers per 10 students. What could we break that down into? It's the same, give me a hand, the same as reducing a fraction. So Jamaica, tell us again. 10 students per 1 teacher could be simplified to, careful, 10 students would become 10 students would become, you were in the right direction, stick with it. Just think about it. If you have 10 over 2, that would simplify to what? Like you just said, say it again. 10 over 2.
5 over 1.
5 over 1. We still have to keep our units here. Okay, so 5 students per 1 teacher. Okay, so when we simplify a ratio, we can drop the fraction, simplify the fraction, but your units must follow. Don't leave them off, okay? Your units must follow it, okay? So when you simplify your rates and things like that, make sure when you simplify that your units follow, however you do it, okay? So let's go to the example. It says Waldo bought $40 over 5 toys. Good. Destiny, give me the other one.
$8 over 1 toy.
Careful. We always got to stick with our original information.
5 toys over
5 toys
What the answer
over $40.
What's the answer again?
She simplified the fraction before we gave our two ratios. Okay, so it asks you what was the ratio in dollars per toy. So that's what Damon gave us first. This was A. And then it asked us for the ratio in toys per dollar. So that's what Destiny gave us, B. For one like that, that's all you got to do. Then we have to simplify. Okay, so Damon, if you were to simplify yours, what would you simplify it? $8 per toy. Another way to write it, right? That's the same as saying $8 per one toy, right? Shamika, how would you simplify Destiny?
What would you say?
No, you. All you, not Destiny anymore, you. If Damon simplified his $8 per toy, you got the same job. Yours is just split.
1 over 8.
1 over 8. 1 over 8 what?
1 toy over $8.
1 toy per $8, right? We could also say 1/8 toy per dollar. Okay, you see that right?
That's complicated.
It's the same. 1 toy per 8.
It's the same, but it makes it seem different.
It makes it seem different, but that would be an acceptable way to do it. We want to make sure we explore all the acceptable ways, okay? So 1 toy per $8, 1/8 toy per dollar.